Okay. Hi, Jonathan. How are you?
Hello, Juan.
What do we know right now about dark matter? What is the dark matter? If this question comes, like
Yeah.
anything, and what can you tell us about dark matter? Like to start.
So we know that the universe contains more matter than what we can see. And so that matter is called dark matter. And it's actually most of the matter. 85% of the matter is dark matter. And so we know it is out there. It's holding galaxies together as the galaxies are spinning around. They're going so fast that if there's nothing else holding them together, we know they should have basically flown apart a long time ago. And so that dark matter is there in the middle. It's holding things together. That's what we know. But beyond that, we don't know anything. We don't know what it's made of. We don't know how heavy it is. We don't know its interactions. And that's what we're trying to find out. I mean, that's the goal.
But there are more things we know about dark matter. Berlin discovered the first evidences of dark matter while studying the movement of galaxies. The stars of the peripheries of galaxies rotate at the same time as those in the center. That made her conclude that galaxies must contain more mass than we can see. That will prove that another type of matter is needed to understand that movement. That is dark matter. Berling's discoveries, which were long ignored, became the beginning of one of the most studied topics in cosmology. Some final remarks. Dark matter is not dark, it is transparent. It does not interact with the electromagnetic spectrum. There is more matter than we can see. Dark matter interacts with gravity and is what makes galaxies possible. Actually, when scientists calculated the way in which the universe is structured, they realized that there is not enough normal matter to explain that structure. The gravity of ordinary matter is not strong enough to form galaxies and complex structures.
What is phaser?
So phaser is the forward search experiment. And it's an experiment that we're launching here at CERN to try to find some answers to the dark matter problem. And what it is it's a relatively small detector. It's about this big, and it's about 5 meters long.
So phaser, these were the magnets, and then these guys are, so there's 4 of these guys at the back of the detector. So the particles come like this, and then they leave their energy in here. We measured the energy as I just...
A particle detector consists on a lead enclosure that contains a series of tiles made from a special mixture of plastic that shines when a particle goes through it. And at the other end, there is a light detector that measures the emitted light.
So in phaser, we only need 4. So the whole detector, you have 2 by 2 to make a square of 4. So the whole of phaser will be this big. So it's pretty small. Compared to, Atlas or CMS.
Apart from the other.
Exactly, yeah. So this was one of the things that I was trying to do, was to a bit like recycle, or it's a bit of a bricolage of trying to.
No, that's very interesting for us. I'll tell you later why, but
okay, yeah,
really interesting.
No, and so this is quite nice because detector components, they're very special and they cost a lot of money and they take a lot of time to design.
Yeah.
And so we don't have that much money, we don't have that much time. Right. So, and because we're very small, so in Atlas the silicon detector covers many square meters, whereas we need just a very small amount. Yeah. So we borrow spare silicon modules from Atlas that they built. In fact, more than 15 years ago they built them, and they tested them, and then they had too many on purpose. So they just put them in a box at CERN, and no one has looked at them for 15 years. Wow. And then last month I and some colleagues plugged them in and ran some tests, and they all worked. Wow. Which was good. And no one knew if they would work, I think. So this was good.
And we're looking for new particles that have never been seen before. And they will be coming out of the proton-proton collisions and going down a very long, about 5 football fields, and then hopefully appearing in our detector. And then if we see something, then we'll have discovered some new particle, which may be related to dark matter.
And that will be a huge discovery, like almost, you will have to give name to that thing, right?
Yeah, that's right. So it's, it'll be really amazing. It'll be a very big surprise. Probably the biggest surprise in 40 years at least in our field. and it will probably signal the beginning of a whole new era, because that particle that we see will not probably be by itself. It will be sort of like the tip of an iceberg, I like to say. It's sort of the particle that will lead to more discoveries. So that's what we're trying to do, is sort of just find that first. The first part is the hardest, because once you find that first one, you can use it to kind of look for other things. But until you find that first one, you don't know where you're looking, really.
Can you tell us a little bit about the process of getting there? Like, you told us you have 2 years to build the detector.
Yes, that's right.
Then what happens?
So we have 2 years before the LHC beam turns on. So right now it's all quiet, and we're going to go down to the tunnel and we can build the detector and install it there. As soon as the beam goes back on, we can't be anywhere near there. And so we have a very strong deadline. As soon as the beam turns on, we better be done. And so then what happens after that is the beam will turn on and we'll start taking data. And the first step is usually calibration, making sure the detector is working. We use like known particles that we understand well to make sure all the components are working, the electronics is firing when it's supposed to, no strange things. But then after we go through that calibration period, then we just sit and look for these new particles. And we probably run for 3 years after the 2 years to install it and then 3 years to run.
How is your experiment related to the big detectors we have right now? I for what I understand, it is close to one of the experiments that's running right now, right?
That's right, yeah. So there's a giant experiment called Atlas, and that detector is, 6 stories tall, huge, and protons collide inside of it. And so we use the fact that the protons collide there to look for the remnants of those collisions. We look for what comes out of those collisions. Our detector is sort of like, like David and Goliath. We're David. Atlas is Goliath. CMS, the one we just saw, is Goliath. Those are giant, enormous, expensive detectors. And we're just a little small experiment.
But David won.
But yeah, that's right. That's why I like that analogy.
Yeah, very good.
But yeah, we hope that we'll find something that they maybe missed.
Yeah, 2 final questions. One, how is it to work like in an international cooperation? Like here at CERN, we've been for a day, and we've seen people from everywhere here. It's like a cosmopolitan place.
Yeah.
How is it to work in an experiment with people from all over the world?
It's amazing. I mean, it's, you have people from all time zones. We have a small experiment of 35 people, but we have 16 different universities, 8 different countries, and they're from, Asia, Europe, the Americas. But they're all unified by this goal to build this thing and make it work. And so, we have trouble scheduling our phone meeting times, because no matter what time we make it, it's going to be midnight for somebody.
Of course.
But, there's little difficulties like that, but it's all worth it, because it's just fun to, come together. And we have, the world expert in such and such is from Japan. Yeah. Okay, so we take him. The world expert in such and such is from Germany. So, you just get the world's best people, put them together, let them talk, let them argue, let them fight it out. But at the end, it's, a good product.
And that happened today, right?
Yeah.
Today is the day that you finally got reunited here at CERN.
Exactly, yeah. So we had our first collaboration meeting in face-to-face. I've been talking to these people on the phone, like Skype and stuff for a whole year now. But I think 90% of them I saw for the first time just yesterday and the day before. And it was just nice to say hello and meet them and go and have a beer with them finally. But yeah, we've been working a long time already.
Wow. Okay, and the last question. So we've been like talking today with the guys, and what do you think about actually a collaboration or the opportunity to talk with artists? You as a physicist, what do you think of the art and science thing that actually Arts at CERN proposes? The reason why we are together.
I mean, it's fantastic. It's really good. I haven't mentioned this to you yet, but I used to be sort of a classical musician, playing trumpet. which is different sort of art. And I always thought that art and my science were a very good mix. And to then see people who actually made that a career and do it professionally, that's a real privilege. It's a real privilege and an honor. And I would also say that there's different areas, but they're in some sense very similar. You use these ways to learn who we are in the world, what is our place in the universe. In the big picture, they have the same goals. And so for me, it's just a lot of fun.
How do you relate, like, being a trumpet? I mean, is there any kind of relationship you did, like being or things that were similar in your way of thinking from when you were playing trumpet or building onto when you were proposing experiments?
Yeah, I think there's some similarities. Oftentimes for, if you're playing in an orchestra or something, you have to work with people. The whole thing is not going to sound very good if you're fighting or something like that. So working in collaboration is huge. And then also the final goal is some beautiful thing. In that case, it's a concert maybe. In the case of this phaser, it's some beautiful experiment that we hope will run and find something. So yeah, there's some real similarities there. It's a good feeling and I think these are fields where it's never really boring,
No, it's never.
It's up and down. Sometimes there's lows, sometimes there's highs.
Yeah.
But there's always something going on, and I like that kind of life.
We all do.
Yeah, I'm sure you do too.
It's like a huge roller coaster.
Yeah, that's right.
Okay, thank you very much.
Yeah,
It's
my
been
pleasure.
an amazing day.
Yes,
Thank you.
it has. Great to talk to you.
Thank you. And thank you. Really, really thank you.
Yeah, my pleasure. Thank you.